that almost contributes 74%. And in terms of industries and transportation, they contribute almost 22 and 22% respectively. But if you see in terms of total emission, okay, that contributes almost 33%. But main culprit, or you can say that it is mainly due to, in terms of the the contribution from us is basically the fuel combustion. Okay. Now, once some of the things we need in our daily life, that's why we have to use this sulfur bearing materials, or we have to use it for our energy purpose. So what are the natural way we can consume this sulfur dioxide? Okay, so the natural process, including the photochemical reaction that take care of sulfur oxides in the atmosphere, forming sulfuric acid as an end product. So then such acid precipitated with the rainfall, so that is a part of your acid rain. Although you don't feel that acid rain, okay, so but the acid rain effect, you see that over a period of time. For example, the discoloration of Taj Mahal. Okay, so out of various regions, one of the main primary contributor is the acid rain, so which is responsible for the discoloration of Taj Mahal. Although this kind of effect, okay, the acid rain is like, if there is the rain is going on, so you can't say that this is acid rain. So you don't feel that. Okay, so the acid comes with the as rain. Okay, then uh, they slowly affect the 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 objects. Okay, and sometimes they end up in also in pool where they change the pH of the pool. But these are very how to say, it's more like over the period you feel this kind of effect. Okay. Now the second, the way the sulfur dioxide is being consumed, so it reacts with O3, ozone, to give you the sulfur trioxide and oxygen. Again, sulfur dioxide may react with oxygen in presence of metal oxide and another pollutant, air pollutant, that is nitrogen oxide, to give sulfur trioxide. And once we have the sulfur trioxide in presence of water droplets, that gives you this H2SO4, okay, or sulfuric acid. So that goes down to earth through acid rain. Sometimes these droplets also give you sulfate salts. Okay, some of them are soluble in and goes with the acid rain or with the rain, and some of them make particulates and also flow with the airflow, or move to the other part of the region with the airflow. So what are the effects it does, this pollutant? So one uh, con- contribution towards is the acid rain, which is very common from two components. For the acid rain, one is the sulfur oxides and the other one is the nitrogen oxide. So the ultimate end product is, one is the sulfuric acid and the other one is nitric acid. In addition to that, these oxides also play an important role in the formation of reducing smog, London smog. So have you heard about this London smog, student?
Yes, sir.
No, sir.
No, never.
Yes, sir, we
So I
are.
heard, sir.
Yes, sir.
So what is that, London smog or reducing smog? One thing is sure, that it happened in London. Yeah, that's why the name is London smog.
Yes, sir.
So what is smog?
It's a combination of smoke and fog.
Smoke and fog.
Combination of smoke and fog. Actually, what happened almost in 1952s, right after the World War. I mean, almost 6 to 7 years of World War. So the high quality grade of coal. Okay, so basically they export those coal material in order to compensate the World War expenses. The low quality coal, they use it for thermal power plants. So in 50s, the thermal power plants are one of the main source for the energy. So in London and also the outskirts of London, the Greater London, they have many power plants based on this coal. So these low grade coals, they have this sulfur bearing materials more in comparison to the high grade. So what happens? So the overuse of this low quality coal, as well as and and in winter, particularly this happened in winter in December. So, and that December was really too cold. So most of the people, the heating system that is in domestic and in also different offices areas, they use this thermal heating generation. So basically burning the coal actually. So excessive burning of coal release a huge amount of sulfur dioxide. This sulfur dioxide release of this sulfur dioxide to the air ultimately gives you this small particles, smoke-like particles. And since it's a winter, so the fog is a common thing to happen. So it mixes with fog to give you the very darkest cover. Almost it's the smog was so thick. It's the visibility within 1 or 2 meters is also difficult. So it was there for almost 7 to 8 days, and during that, the vulnerable people, mostly the elderly, as well as the people having the asthmatic condition or having some uh, breathing related diseases, and also the vulnerable category, the children. So they are affected by that smog, and almost uh, 10,000 to 12,000 people died during that period. Maybe this is the official number, but I think the number is more than that. So it was one of the biggest, I would say, the air pollution catastrophe in 1952. So after that, then there are many rules and regulations are being uh, uh, they act upon it, and so to improve the air quality. Now, if you go to Europe, it's one of the best places in terms of air quality, and summer is the best time to go there. So so sometimes we learn things by experiencing it. So this is what we are experiencing at the moment in India, particularly all the big cities like Delhi, Mumbai, and also Kolkata. And the air quality is really poor. I mean, and we started to act upon it. So that's why we are also replacing all this petroleum-based motors with vehicles. Although the process is in the preliminary stage, but probably you have already noticed that all the most of the two-wheelers are not most, but many companies are coming up with these two-wheelers with EV or battery. So I would say in 5 to 10 years we will have the roads dominant by the EV vehicles, and and nowadays nobody is using also the thermal power plant as a coal based thermal power plant. But although we have in Odisha, do you know we have a thermal power plant in Odisha? Anyone?
Sir,
Any?
Talcher.
Yes. So although we use it, but anyway, this is very limited to a few numbers. Even in Europe, it is reduced to few numbers, very less. The coal-based thermal power plants are nowadays being used. But anyway, so the main culprit was the burning of coal. So what happens? This sulfate aerosols, these are very small in size. Just a moment. Okay, sorry about that, students. Okay. So there's the sulfate aerosols. They're very small in size. The size is almost less than 2 microns. Okay, and therefore it can easily go to your lungs. Okay, so basically the pulmonary region, and it can cause severe respiratory troubles. Okay? They're very small in size. So this is the effect of sulfur oxides once it's released to the air. Okay. Now the next the air pollutant we'll be discussing is the hydrocarbons. Okay. So we have almost 20 different hydrocarbons identified. Okay. So many of them are very common organic compound like methane, ethane, ethylene, acetylene, propane, butane, toluene, xylene. Okay. So they're very common. Some of them we also use in the lab. Okay. Methane is the major naturally occurring hydrocarbon. Okay. So in terms of its source, particularly for hydrocarbons, the natural source is the anaerobic decomposition of organic matter. So this is a very common phenomenon. I mean, also we use it as our purpose, like the cow dung plants. So that is basically the anaerobic decomposition of cow dung. So that gives you the source for methane gas. And in terms of man-made contribution, or the transportation is contributing almost 55%. Incineration, okay, incineration of dead bodies, that also contributes almost 28%. So incineration also releases very toxic gases. So, and coal and wood, although their contribution is very, very less, so it's almost 2%. Solvent evaporation, so that also contributes almost 11%. So this solvent evaporation is normally what we use in our lab is all the uh, uh, basic organic compounds that sometimes we use it for synthetic purpose or in synthesis, and it's very common that we may release that. So although you'll not release the solvent inside your lab. Normally we do that work inside the fume hood. But anyway, the function of fume hood is to just take or extract the air and release to the atmosphere. So ultimately it goes to the atmosphere. So nowadays what we do, or we try to practice in laboratory, that how to replace this organic solvent by solvents which are more greener in nature. Greener in the sense that are less harmful towards the environment. So, so if you see many of the synthetic process in lab as well as in industrial level are replaced by more greener solvent like ionic liquids. Okay. Then we have also supercritical fluids, supercritical water. Okay. That we will discuss when we will discuss in green chemistry. Okay. So the green chemistry, that is the preventive method. So what are the things we can do so that we will affect less to the environment? So it's a protective measure, you can say that. So the solvent evaporation is also contributing to the release of hydrocarbons to the atmosphere. So in terms of percentage, if you see, it's almost 15% of total global emissions. Okay. It is lesser than the oxides like sulfur oxide, but in terms of impact, okay, in terms of impact towards the global warming parameter, you see the hydrocarbons has more in comparison to the normal oxides or the greenhouse gases. Okay, so similar to your London smog, there is another event happened in history, that is your photochemical smog, that is or sometimes it is known as Los Angeles smog. As you know, this is smog is a combination of smoke and fog. So it is formed in atmosphere loaded with hydrocarbons. So the first one, the reducing smog or the London smog, the main contributor is the sulfur oxide. So here the main contributor is your hydrocarbons. Okay. So it initiates a complex reactions. Okay. And a number of secondary pollutants are being generated during that photochemical oxidation process. So And in terms of its physical appearance, this Los Angeles smog is brown, hazy fumes, and main effect is you get the eye irritation, and also it also penetrates to your lungs. Okay, so ozone and PAN. So this polyacyl nitrate, the both O3 and PAN are the secondary pollutants, whereas the hydrocarbons and the nitrogen oxides acts as a precursor to produce this pollutants. Okay, so we will see the formation of the smog. So what happens? The hydrocarbons reacts with ozone that is in our atmosphere. So that gives you basically this alkyl radicals. Okay. So again, this alkyl radicals reacts with oxygen to give you this oxyalkyl radicals. That again reacts with nitrogen oxides, and during that process, it produces nitrogen dioxide. Okay, and also this oxyalkyl radicals reacts with oxygen to give you this hydroxyperoxyl radical. Okay, so from this point, okay, so you have one is hydroxyperoxyl radical, and the second one is this stable aldehyde. Okay, this aldehyde is responsible for the formation of PAN. Okay, so but once you have this hydroxyperoxyl radical, so it again creates this chain reaction. Okay, so that reacts with nitrogen oxide to form hydroxy radical and nitrogen dioxide. Okay, that is again another pollutant, and when it reacts with the hydrocarbon RCS3, that gives you the radicals. Okay, so since due to this chain reaction, so presence of few hydrocarbons can be catastrophic in creating the secondary pollutants. Okay. So, but in terms of impactness, if you see, these are more have more power to give you this global warming effect compared to other pollutants. Okay, we will see that also in comparison. So how this peroxyacyl nitrate formation is happening in atmosphere. So once you have this stable aldehyde that reacts with hydroxy radical, that gives you this another radicals, that oxide radicals. So in presence of oxygen, you have this peroxyacyl radical. Okay, so this peroxyacyl radicals reacts with nitrogen dioxide, that is another reactant, to form this PAN. Okay, so this peroxyacyl nitrate. So this PAN is the main contributor for this Los Angeles smog. Okay, or this photochemical smog, and the main effect of this pollutant is it gives you an itching effect to your eyes. Or now, in terms of effect, besides this itching effect, so it also damages the vegetation and also decreases the crop yield. And another phenomena you see, maybe you have noticed that the rubber, okay, so the rubber materials, if you leave it for a long time, and long time means it may be like can be a month or can be years. So you see this is the rubber becomes more brittle in nature. Okay, so if you stretch it, so the elasticity loses and it breaks down. So cracking of rubber, okay, it happens due to this PAN pollutant. It also creates also corrosion in metal structure. So this is highly corrosive in nature. So that's why you also get this etching effect in your eyes. So this is the main effect of this the secondary pollutants from the hydrocarbons. Okay. The London smog we have already discussed partly. This is a mixture of smoke and fog. Okay, and it happened in 1952 in London City, and the reason due to this overburning of this sulfur bearing materials. So basically, the coal is responsible for that, and once the sulfur dioxide forms, this then they reacts to form the sulfur trioxide, and in sulfur trioxide in presence of water, that gives you this sulfuric acid droplets. Okay, And these droplets then condense on the carbon particles of soot, that is the smoke, and the smog, which is formed known as the London smog. Okay. So one is due to the sulfur oxide, that is the London smog. The other one is the Los Angeles smog. Okay, that is basically due to the hydrocarbons. Okay, so these are the two events happen in history, and they are the two catastrophic air pollution effects. The next category in this series is your particulates. Okay. So these are small solid particles and liquid droplets. So they're collectively known as the particulates. The size mainly vary from, okay, so the number here is slightly wrong. It is 0.002. Okay, so roughly 2 nanometer to 500 microns. Not microns, so it is nanometer. So this is wrong here. So it is 0.002 to 500 nanometers. So 500 nanometer means almost it would be like how much? 1,000 microns. So it would be, yeah, so 50 microns or something. The lifetime may be from few seconds to several months, depending on its circulation, or because it may react with and it come in contact with solid object and stick. Okay. The settling rate depends on the size and density of the particle along with the air turbulence. And due to very large surface area, they provide good sites for absorption of different materials. Okay. So this is the dangerous part. Okay. So due to its large surface area, this particulates, so they can absorb different toxic materials. Okay. So they're not limited to particular kind of disease. So they can spread different kind of diseases depending upon what kind of toxic materials are being absorbed on the surface. So this is also the main reason the spreading of different types of diseases. The particulates are the main culprits. In terms of classification, these particulates can be divided in two categories. So one is the inorganic particulates, the other one is the organic. In inorganic, we have this metal oxides released during the fuel combustion. So that basically consists of this iron oxide, calcium oxide from the calcium carbonate. Then you have lead halides during the combustion of gasoline. Sulfate and nitrate salts formed in atmosphere. Okay, so that is basically comes from sulfur oxide and nitrogen oxides. In terms of organic particulates, we have this basically the aromatic hydrocarbons, so commonly known as the PAH or polycyclic aromatic hydrocarbons. So the common examples are this chrysine, benzoalpha pyrene. Okay, so mostly the aromatic hydrocarbons in particular. So basically, these are being released from different types of industrial activities where the solvent or the process involves organic solvents. Source, in terms of source for this particulates, so obviously the volcanic action, blowing up dust, soil by wind, spraying of salts by sea. But in terms of man-made contribution, so fly ash industries, mining activities, constructions. Okay. So these are the main source for the generation of particulates, the release of particulates to air. Now, what type of effects we have in terms of affecting? So one main contribution is the respiratory problem. So due to their size, so their size is very, very small, so it can penetrate to your lungs, particularly the pulmonary region, and you may have different types of breathing related diseases. Asbestos, so that contributes to the pulmonary fibrosis. Other toxic metals, for example, barium and arsenic, they are carcinogenic in nature. Okay. So normally you don't feel that immediately this kind of inhalation of materials. So over the period, if you're exposed to beryllium and arsenic, the disease or the cancer disease may come after 10, 20 years. So this happened to the person, those who are working in these areas where the release of barium and arsenic is a common thing. Uh, the release of inhalation of lead leads to different types of bone marrow disorder, renal dysfunction. Uh, Cadmium is responsible for this Itai disease, so that has been discovered, identified in Japan. So which is a due to this, the bones become fragile, and you see different types of defects uh, 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 with the newborn also. So then mercury is basically uh, responsible for the brain damage, and also similarly mercury also is highly toxic, highly poisonous. So Minamata disease, if you remember, that is also identified in Japan because of this mercury poisoning. So what happened for the Japanese people? The Since Japan is surrounded by sea, so the seafood is one of their main staple food. So so what happened in I don't know exactly the year, but the release of mercury from an industry to local stream, and that stream again ended up in sea, and this mercury is taken by the fish, and when the fish is taken by the human, because the Japanese people love fish. Okay, so they have different types of fish in the daily food. So they will eat as it is raw, but also with slight marination. So by consuming all this fish, so finally mercury is ended up inside our body, and that leads to different this Minamata disease. So the Minamata disease is basically gives you different types of defects. Defects in the sense like you have defects in the limbs, also hands, and also legs. So and also it affects your also brain. Okay. So these are the different types of or diseases due to this particulates. And although these type of air pollutants are limited to particularly some region, because it's mainly depends on the industrial activities having this kind of material. But nowadays we have strict regulations of using this type of toxic metals. So, and even if a process is needed to have this type of or involvement of these toxic metals, so we do it in a very controlled manner, so that less or very few toxic metals will be released to the atmosphere. So we control that nowadays. We control it very strongly. Okay, so that's why we don't have this kind of only one incident. You can say that the air pollution incident that has happened in Nepal in 1983 or 84. This release of methyl cyanide, which is very toxic in nature, and we can see that effect also still in Bhopal. Sorry, not in Nepal. Sorry, Bhopal. Okay. So, but in recent years, so we don't have such type of air, like accidents due to air pollution. So very rare nowadays. Okay. So the next is the ozone layer depletion, but we will discuss that in the next class. So in the next class, we'll be discussing more about the global event, okay, or the global effect of air pollution. So in that category, we have this depletion of ozone layer. We have also the melting of ice in the Arctic region, and also the global warming phenomenon. Okay. But besides that, there are many events. I mean, there are many global events due to the air pollution. So, but we will limit our discussion to these things. Okay. Okay, students. So, anything you want to discuss?
No, sir.
Okay. Okay. So, yeah, I think a couple of days back, one student wrote me about, I don't know from this section or from other section. So he was giving a topic about Amazon deforestation. Okay. So since that topic is not in our list, but one can also use that. Okay, because this is also one of the global event, or the deforestation in Amazon is a really a global headache also. Uh, Besides that, there are also many different types of environmental issues. So I would suggest that don't limit your uh, PPT or in particular the innovative write-up to the topics that I've given to you. So you're free to choose, but the condition is, as I told you, look for any problems which is more the environmental problems. Uh, Maybe it's very local to your region or to your state, or maybe it's a national problem. We have many different types of environmental problems. So be more innovative in choosing the topic. So please share it with me. So if I like it, like
Excuse me,
it.
sir.
Yes.
Sir, there was a slight confusion with the presentation and the write-up. So the
Okay.
presentation is a group project and the write-up is the individual project, right?
Yes. Yes.
So for the write-up, we choose our own topics, or are you going to provide us a list?
No. The list is that. Okay. So, but you are free to choose. Either you can use that same topic. Okay, that's absolutely fine. Or you can choose the topic from the baskets. Okay. Or you're free to choose any other topics which is like environmental problem. Okay.
So the list of topics is the same for the presentation as well as the write-up,
Yeah.
right?
Yeah.
Okay, sir. Thank you, sir.
Excuse me, sir.
Yes.
So we have to write the write-ups individually or in a group?
No, individually. Write up is purely individual.
Okay, sir.
Okay.
So you have not provided that topic bucket, sir.
I haven't provided.
No, sir.
Students, I haven't
No,
provided
sir.
the topic.
You have shared the topics.
No,
I
sir.
haven't shared it.
No,
Okay.
sir.
But I'll
You
show
have
you.
shared in a yes, sir.
Yes, sir.
You have
Only you have
presented
showed
it.
in that in presentation.
Okay. Let me do that. Okay. Let me do that now. Cycle. I haven't said anything. Yeah. Or I just only shared this. Only the
Only you have shared.
PPT is okay. So just a minute. I'll put it now. Okay, it is there now. So I also put the format for the innovative write-up. Although this format is a very general one, having like introduction and subtopics, but you can choose your own subtopics.
So this we have to submit before end semester, no, sir?
Yeah, I'll give you exact date. Ideally, if your end sem is second
July.
week of June or July. I don't know. It may.
Sir, sorry, sir. The innovative type topic is just the write-up, right? We don't have to do any kind of presentation for that.
Which one? Which one?
So for the innovative topic write-up.
No, for that you don't have to present anything. Only the
Okay.
write-up, report writing.
Okay, sir.
Okay.
So that has to be typed or handwritten?
It can be anything. It can be handwritten, can be untyped. Okay.
Okay, sir. Thank you, sir.
Okay, sir.
Sir, can I ask one topic, sir, related to that? Is that
Yes.
I have is that why India is facing pollution in the month of most in the month of January and February? This topic is suitable for writer.
Do you have a valid reason for that? Why?
Yeah, sir. I have researched IIT Kanpur research there, sir.
Yeah. Then go ahead. Go ahead.
Okay, sir.
So students, yeah. So you're free to
We
choose.
have to submit this before end seminar.
I think ideally, I would say, I mean, we'll fix a date because it's March, April. Ideally, mid of May or something like that. So you'll have almost 2 months to go. Okay.
Okay, sir.
Sir, how many words, word limit? What is the word limit for
I
this?
think this, particularly for this innovative write-up, is better if you keep your write-up in 3 to 5 pages. Okay, not
Sir,
more
we
than
can
that.
type.
You can type. You can type.
Okay.
What is important here is okay. Although I gave you a format for that, but you can short your introduction part. What is the problem exactly, and what is your idea about or giving a solution for that problem. So limit your discussion in 3 to 5 pages. Okay, okay. It may go up to like 6, but don't extend to like 10 pages or something like that. So limit maximum 5 to 6. Okay. So three can be accepted if it's your idea is a very short one. Okay. Impact one, so that is also acceptable. That is not an issue. Okay. Clear?
Yes, sir.
Okay, so anything you want to discuss from what we discussed from today's topic? Because the quiz would be up to this. Okay.
Yes, sir.
Okay.
Sir, what will be the timing, sir? It's 10:30.
No. Yeah. 10:30 exactly. 10:30. 10:30
Okay.
exactly 20 minutes. So
Okay,
the
sir.
form will automatically closes around 10:50. Okay, and don't panic if you don't receive the link exactly at 10:30. If you get it like 2-3 minutes later, so I'll consider that okay. The time when you receive the link from there 20 minutes. Okay,
Okay,
because I
sir.
automated
Okay, sir.
sometimes due to give Google server problems, so they release the link just 2 or 3 minutes later, or sometimes earlier. Not earlier. I haven't seen that, but mostly the later. Okay, so don't
Yes, sir.
panic with that. Okay, clear, students?
Yes, sir.
Yes, sir. Sir, still didn't get receive that in classroom, sir. That how
In
to write.
class,
Yes.
can you access the files in classroom, Shivam?
Sorry, sir. How?
Hmm?
No, sir.
No.
No, sir. Still. No.
Okay, I'll give you a link now. The link is for this folder. Okay, so maybe.
Okay, sir.
I think I have already given that link in the previous. Yeah.
Yes, sir. It is there.
But okay, there is directly a link for that PDF. Sorry. So, but this I will give you this link for that folder, for your classroom folder. I don't know why some of the students are not able to access this folder.
Sir, the quiz is now at 10:30.
10:30. 10:30.
Okay, sir.
Okay. Can you try Shivam now?
Yes, sir. We are able to access it, sir.
Yeah. So that's fine. Okay. Okay.
Yes, sir.
So
Thank you, sir.
okay. So shall I close this meeting? So
Yes, sir.
Okay, so if we do not have to discuss anything, so we can close it, and exactly at 10:30. So you'll see. Exactly means okay, maybe 1-2 minutes, but don't panic.
No, sir. Will not.
Okay, sir. Thank you, sir.
Yeah.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.